G'day. Copy the heading down, then the numbers 1 to 6 down the left-hand side. Answer these 6 questions. Question 1. Carbon-14 is a radioactive form of carbon made by the bombardment of nitrogen at the top of the atmosphere by the solar wind. It has 2 more neutrons than normal carbon and is used to date old skeletons and campfires. Is carbon-14 an isotope or allotrope of carbon? Question 2. Ozone has formula O3 and normal oxygen O2. Is ozone an isotope or allotrope of oxygen? Question 3. Which chemical element was given the name brimstone by early British Bible translators? Question 4. Is the ozone layer in the troposphere, stratosphere, mesosphere or ionosphere? Question 5. Which chemical element is converted into soil fertilisers by legume plants? Question 6. What 2 poisonous chemicals are converted by catalytic converters in car exhausts to harmless forms? Group 7 in the periodic table includes fluorine, chlorine, bromine, iodine and astatine. Astatine is an artificial radioisotope made experimentally by some particle bombarders in 1940. Astatine quickly decays to other things, so we will speak no more of this phantom or the 3 particle bombardiers who first made it. The Group 7 elements were called halogens by the French and European chemists who discovered them between the years 1774 and 1886. The 4 main halogens are extremely reactive nonmetals because they have an almost complete outer shell of 7 electrons. So they are desperate to find another electron to fill their outer valence shells. They will grab electrons from metals, forming ionic salts in a series of violent reactions that should never be done in schools. Though the compounds formed can be stable and often vital to life. Halogens will also react with nonmetals and even inert gases by sharing electrons. Some of the compounds formed in these reactions have a variety of uses. However, many of these chemical compounds are beginning to haunt us as they can harm living things, cause cancers, and even wreck the ozone layer. It is a case of knowing your chemicals. The halogen elements can be good friends and terrible enemies. Copy and complete. Make a heading for our first halogen, fluorine F. In the late 1960s, I took a group of students to the Newcastle Steelworks, where the steel workers were using the mineral fluorite in their furnaces to lower the temperatures at which things melted. Fluorite is calcium fluoride and is found in veins in some granites. Fluorite received its name because it fluoresces under ultraviolet light. Energetic black ultraviolet radiation is converted to bright visible light. We have since discovered a number of minerals and chemicals which are fluorescent. Some fluorescent chemical powders are used to make washing and paper brilliant white. This particular chemical here is called fluorescein. It finds uses in highlighter pens. You might like to use different coloured highlighters to draw pictures on paper and to hold them near an ultraviolet lamp. We use fluorescent chemicals to tag living cells and to help with our DNA tests. Copy and complete. Fluorine gas just happens to be the most reactive of the chemical elements. It will bond with just about anything, including some inert gases. Organic chemicals, metals, non-metals, and even water will burst into flames in its presence. So you can imagine what it does to people. The pioneer chemical researchers who tried to extract it from its compounds were like lambs to the slaughter. A number were killed or blinded and became known as the fluorine martyrs. Fluorine research began early, with metal workers using the ore fluorite in their blast furnaces. Eventually someone found that if you added concentrated sulfuric acid to fluorite, under special conditions, a gas called hydrogen fluoride was produced that formed hydrofluoric acid with water. Hydrofluoric acid is not exactly a cuddly little chemical. It dissolves most plastics, flesh, and even glass. Notice that there are two symbols on the bottle, a skull and crossbones for danger, and a second symbol for it being a corrosive acid. I found a bottle in my school and refused to touch it. Artists, unfortunately, have used it for years to etch glass. Others use it to etch bathroom tiles to make them less slippery. There are too many safety issues with this chemical. The fumes should never be inhaled, and it is easily absorbed into human skin and will penetrate down to the bones. Occasionally, amputations have been necessary to save people's lives. Always obey safety instructions with chemicals. A number of Teflon-based products emit hydrogen fluoride in factory and household fires. This is one reason why smoke in fires is a major killer, and our modern firefighters need to wear oxygen tanks and hazmat suits in their heroic efforts to save lives. Copy and complete. Tooth decay is as old as humankind. It occurs when sugars and starches encourage bacteria to build up plaque deposits around the base of teeth. These cause acids to dissolve the protective enamel of the teeth. The softer tooth parts are then invaded by bacteria and the teeth go rotten and die. The infections can weaken the whole body and even cause heart disease. Consequently, our ancestors had rotten teeth and shocking bad breath that they disguised using smelly plants and flowers. They were pretty desperate. 200 years ago, there was a good trade in false teeth made from elephant tusks, walrus tusks, and even the teeth ripped from the huge pile of dead left behind on the dreadful Waterloo battlefield. My grandmother's family solved their dental problems by having all their surviving teeth ripped out without anaesthetic and replaced with dentures. They were tough in them there days. I was unfortunate enough not to be exposed to fluoride as a child. Consequently, all my teeth have suffered decay, and I have spent many hundreds of painful and expensive hours in dentist chairs. Mercury amalgams, crowns, and root canal therapy are not pleasant experiences. In contrast, my wife and children have benefited from drinking fluoridated water, brushing with fluoride toothpaste, learning to use dental floss, and having the odd fluoride treatment during dental checkups. They have no tooth decay. Concentrations of about 1 milligram of fluoride compound per litre in 60% of Australia's drinking water have reduced dental decay substantially. The fluoride levels are carefully monitored by chemists. My advice is not to filter out fluoride from your drinking water. You should brush and floss your teeth at least twice a day. You can eat sweet foods, but try not to snack on these things all day. The dentist will scale your teeth to combat plaque and may apply fluoride treatments. The moral to this story is that fluoride chemicals have played a large part in reducing a major Australian health problem. The fluoride ions partly transform the hydroxycalcium phosphate in tooth enamel to fluorocalcium phosphate. This chemical is a very common chemical in nature and improves our body's defences against plaque bacteria. In this break, we will give you some time to write a sentence about fluoride and tooth decay. Make a heading for chlorine Cl. Most of the salts left behind when seawater evaporates consist of chloride compounds. The water we have in our body cells is also salty, and we have a taste for salt. So even though chlorine is the second nastiest of the halogen elements, it is also an element of life. Its compounds are often safe and useful. Chlorine is easily extracted from seawater using electricity. The chlorine forms at the positive electrode as little bubbles in the water. If you do this experiment using a battery or power pack, you will quickly learn to disconnect the power. Chlorine has a most unpleasant choking smell and will wreck your lungs before it kills you. Older submarines ran on battery power, and submariners dreaded damage to the sub, where salt water would enter the batteries. Chlorine gas has a pale yellow-green colour. It dissolves readily in water and backyard pools, and has a bleaching action on a range of coloured chemicals, including indicators. They lose their colour. Australia's World War I generation had a particular dislike of chlorine. At the outbreak of that war, Germany's most celebrated industrial chemist was Fritz Haber, who headed the Kaiser Wilhelm Institute for Chemistry. His claim to fame was a high-pressure method for making ammonia and then the explosive compounds that could be created from it. As a good patriotic German, Haber had the idea that chlorine could be used as a poison gas to end the war swiftly. His team released hundreds of tons of chlorine in 1915 in 2 attacks on the Western Front, causing 15,000 casualties, with 4,000 dead, including 1,000 Germans. That should have been a warning, but Haber headed for the Russian front to do it all again. The Allies soon responded in kind. More deadly chlorine compounds, including mustard gas and phosgene, were introduced by both sides in a war of the chemists. By war's end, 90,000 had been killed and 1,240,000 injured by chemical weapons. Many young Aussie soldiers returned from that war with their lungs ruined. The former Prime Minister's father, Lyle, was one of many. To its credit, Australia was the 6th country to ban the use of chemical weapons. But there is a better story about chlorine. Since the beginning of human history, many diseases have infected drinking water supplies. These include gastroenteritis, dysentery, diarrhea, cholera, and typhoid fever. As communities became larger, the problems became more acute. All countries have experienced major epidemics in the past. Today the world continues to be in crisis, with poverty, overpopulation, shanty towns, polluted waterways, and even wars triggering major epidemics. The closest crisis presently is centred on the Ley area in New Guinea, whose health system is in a state of near collapse. Pollution in overcrowded shanty towns has produced a major outbreak of highly contagious cholera and dysentery, with many dead and thousands affected. Australia had similar experiences in our early settlements. The first Sydney water supply was the polluted tank stream, and then the ponds of Centennial Park. The diseases of bad water kill by dehydration, and children and babies can die very quickly as they run out of water. Country communities also had these scourges, as old gravestones testify. Modern treatments include antibiotics, disinfectants, and giving patients lots and lots of fluids. Our visionary scientist engineers built dams on special reserves around Sydney. Then they learned about chlorine and began to add small amounts of the chemical to kill the nasty microbes that are found in most water supplies. Most of the diseases that I have mentioned are now rare, except for gastroenteritis, and most children survive to high school age. In my childhood, we drank tank water, but we always boiled the water for drinking. It was amazing the wildlife that died in those tanks. In the home, the principal source of chlorine is sodium hypochlorite, or liquid bleach, which you may use as a bathroom or shower cleaner. You should avoid its fumes and be careful of the eyes, as it is a very dangerous alkali. Chlorinated pools also emit chlorine, which sensitises the lungs. A number of organochloride compounds used as pesticides, insecticides and herbicides, such as chlordane, DDT, heptachlor, dioxin and endosulfan, do nasty things to humans. We are learning to do without them. The manufacture of PVC conduit, siding, glues and paints also produces toxic chlorine byproducts. Copy and complete the following, then put a heading for our next halogen element, bromine. Bromine is a hellish-looking red liquid stored in capsules. Don't be too curious with this one, or it will bite you on the nose. Ow! The French chemist Antoine Jerome Ballard first recovered bromine from seaweed ash in 1826. The salts of the Dead Sea are also rich in bromide chemicals. Bromine is the only liquid halogen at room temperature. It is not very soluble in water and evaporates very easily. This makes it the most dangerous of the halogens to work with, as it is easy to breathe in and wrecks the lungs. Whilst bromide salts are quite stable things, the addition of chlorine or oxidising agents to these chemicals, such as potassium permanganate, easily causes the bromine to form. The antidote to turn it back to bromide again is the reducing agent sodium thiosulfate. The biggest use of bromine chemicals is in flame retardant chemicals added to many plastics such as polystyrene to stop them burning easily. Another widely used bromine chemical is methyl bromide. It is used to kill rats in wheat silos and to get rid of nasty pests such as nematodes in soils. Curiously, this chemical occurs naturally in some plants, including broccoli, cabbage and mustard. So plants can use toxic chemicals just as well as humans. Copy and complete. Like chlorine, iodine is a vital element of life. We need some iodine in our diet so that our thyroid glands can make a range of hormone chemicals, including thyroxine, which regulate our body's temperature, growth and heart rate. Many of our first Australians obtained their iodine from shellfish and seafood. Australian soils are often exhausted and deficient in iodine. Without this element, the thyroid can become inflamed and form goiters. The Aussie government intervened and our salts are made to contain some iodine compounds to prevent iodine deficiencies. Historically, iodine was made from seaweed ash. Poor Frenchmen, fishermen, made a living by roasting seaweed in trenches. The element iodine is greyish-purple in colour. When heated, it forms a purple gas that should not be inhaled. Iodine dissolves not in water, but in alcohol, forming a brown solution. Iodine, alcohol and potassium iodide solutions are sold as betadine and tincture of iodine. They are still the most effective antiseptics for use on wounds and in surgery. A few drops of these chemicals will also kill germs in water. Copy and complete. Ultraviolet light from the sun is divided into 3 spectral bands: UVC, UVB and UVA. UVC is the most harmful and is capable of blinding us and sterilising the planet. This graph shows you where the ozone layer is above the Earth. Most of the UVC is blocked by the ionosphere above the ozone layer. The ozone layer itself blocks most of the UVB and some of the UVA. The UVB that penetrates can cause skin cancers, eye cataracts, and damage to crops on land and plankton in the sea. Beginning around 1970, scientists noticed a drop in ozone at the poles and an increase in ultraviolet. Antarctic measurements in 1985 were alarming. The nastiest reactions seem to occur in high clouds over the South Pole when the temperature is very, very cold. The final chemical reactions occur in spring, where ozone can drop by as much as 70%. In September and October, ozone levels drop alarmingly over South America, Australia and New Zealand. It is affecting the whole world, which has lost about 4% of ozone per decade since 1970. The causes seem to be carbon chemicals containing chlorine and bromine, and other chemicals such as nitrogen oxides. These break up the ozone molecules in the stratosphere. The world reacted with an agreement signed at Montreal in 1987 to start banning chemicals. The most destructive chemicals are being phased out first. The worst are the bromine chemicals, or halogens, including our rat-killing methyl bromide. There are other ways of suffocating rats. Next are the CFCs, or chlorofluorocarbons. These were used in refrigerators, air conditioners, fire extinguishers and a blow-up foam plastic. CFC 11 and CFC 12 were the worst chemicals. Carbon tetrachloride and chloroform are also on the list. They are carcinogenic as well. HCFCs are the replacement chemicals, but they can do damage too. Hopefully they will be replaced by HFCs that contain no chlorine. If all goes well, the ozone layer may repair by 2075. In the meantime, Australia will suffer almost as much as South America and New Zealand. Expect crop damage, skin cancers and cataract operations when you reach my age.